This video is some odd-numbered exercises from your Chapter 1, the end of the chapter exercises, and I'm in the 6th edition of the textbook that we're using by Stephen Stoker. The questions that I'm going to be talking about are 10, 12, 22, 24, 26, 30, 32, 34, 38, 40, and 70. And so if you want to take a few moments and do those, or even do a chunk of them, and then come back and watch me work the solutions, that might be a great idea. I highly recommend not just watching me do the solutions, because that's not helping you to learn. That's just letting you watch me do what I already know how to do. So make sure that you're making your learning experience really rich here and that you're really engaging the content. So let's get started. And you can either stop the video here, or you can, well, actually I'd recommend you stop the video here, do the problems, and then come back. So number 10. Number 10 says, the following are properties of the metal lithium. Classify each property as physical or chemical. And so we want to recall what physical or chemical changes are. So physical changes, remember, cause a change in the physical state of the substance, but no change in the identity. So for instance, I could have an atom of some type, and it could undergo a physical change. Actually, let's make it a molecule of, I'm just going to make different shapes, and make different shapes equal different atoms. So I've got a triangle and two circles in this molecule, and if it undergoes a physical change, it's still a triangle and two circles, right? Only here, maybe it was a liquid, and maybe over here, it's a gas. So that's what a physical change would do. If instead I was doing a chemical change of my molecule, if I had a chemical change, then I would see some bonds breaking. So, or forming new bonds. Now, since I only have one thing to work with, I was only breaking bonds. But I could make some bonds too if I had more reactants to work with, but I don't. But you see what happens here? Here I had a triangle bound to a circle bound to another circle. Over here, I have a triangle by itself, and two circles, excuse me, bound to each other. So clearly, the identity of my substance has changed, because now I have different combinations. I have different bonding combinations. So here we had a change in identity. So whenever we're trying to decide whether something's undergone a physical change or a chemical change, we're really looking at, does a substance undergo a change in its identity? Am I breaking bonds? Is the process reversible? Can I get the same thing back? So in number 10, we're looking at lithium, and we want to classify each property as physical or chemical, and A says reacts vigorously with water. Well, heads up, right there, key word, it says reacts. And anytime you have the word reacts going on, what's that going to tell you? Oh yeah, that's definitely a chemical change. Right? Chemical changes are reactions. So if I say something reacts, then pretty good tip that that's a chemical change. In B, it says the density is 0.534 grams per milliliter at 20 degrees Celsius. So we need to think about this. Can I measure the density of something? Can I measure the mass and the volume of some substance? And when I do that, does it change the identity of the substance? Well, no, it doesn't. My measuring the mass of something doesn't change the identity of the substance. We can measure your mass. It doesn't change who you are. So in B, so A was definitely chemical. In B, measuring the density, that's a physical change or a physical property. Oh, excuse me, we're looking at properties. So that's a physical property. In C, it says it's a liquid at 200 degrees Celsius. Again, we can observe the fact that it's a liquid at 200 degrees Celsius, and that has not changed the identity of the substance. So C is going to be physical as well. And then D has a soft consistency. We're essentially checking its texture. I can do that, and still have lithium when I'm done. So B, C, and D are all physical properties. Let's look at number 12. It says, indicate whether each of the following statements describes a physical or a chemical property. Diamonds are very hard substances. Well, if that was a chemical property, then by measuring the hardness of diamonds, I would have changed the identity of the diamond, and that's not what happens. So that is a physical property. In B, it says gold metal does not react with nitric acid. Now this one's kind of tricky because it says gold metal does not react with nitric acid. So it tells you that something's not happening, and so you might be tempted to say that that's a physical property, but remember this is a reaction not happening. And anytime we hear the word react, we should say ding, 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 that's chemical. So for number 12, so far we've had diamonds were very hard substances, that's physical. And something does not react with nitric acid, that's talking about a chemical property. It's talking about whether it reacts with something or not. In C, lithium metal is light enough to float on water. That's talking about the density, actually, of lithium. And so that's physical. And then D, mercury is a liquid at room temperature. Again, we can measure it. It doesn't change the identity of it. It's reversible. And so that would be a physical property as well. Now, let's look at 22. 22 says classify each of the following as a physical property, a physical change, a chemical property, or a chemical change. So now we're getting in the idea of, are we measuring a property of something, or is something occurring? So in A, it says the process of decomposing hydrogen peroxide. Well, right there, key word, it says process of decomposing hydrogen peroxide, which tells me a change is occurring. And then the question is it a physical change or a chemical change? Well, we're decomposing hydrogen peroxide. Decomposition is an example of a chemical change. So 122A would be a chemical change. All right, what about B? Well, in B, the fact that a block of ice can be chipped into smaller pieces is that's an interesting one, because the fact that a block of ice can be chipped into smaller pieces sort of suggests we're talking about a physical property. It's not saying that the block of ice is being chipped into pieces, it's saying that it can be. So we're talking property. And physical, because if I chip a piece of ice off another larger piece of ice, do I still have ice? Well, yeah, I do. So definitely reversible there. And we haven't changed the chemical identity of our substance. C says the process of evaporating a liquid. Again, there's that key word of process. This time we're evaporating a liquid. And if you think about it, evaporating a liquid is a reversible process. So this is talking about a physical change. In D, we have the fact that water freezes at 32 degrees Fahrenheit. This is a physical property. All right, that's 22. Let's talk about number 24. I need a new slide. Oh, shoot. Oh boy. Let's go back up here to the first slide of my mini blank slides and go back to my, there we go. So number 24 says classify each of the following statements as true or false. And in A, it says all homogeneous mixtures must contain at least two substances. So what we're talking about is if I have, let's say, some stars running around, and I also have some hearts, do I have a mixture? Versus if I only have one type of thing running around. Well, if you've read Chapter 1 and you've done some homework problems and you watched the Chapter 1 integrity video lecture, then you know that the definition of a mixture is it's two or more substances that are physically combined. So this would qualify as a mixture, but this would not because there's only one type of substance there. We just have stars. So all homogeneous mixtures must contain at least two substances. That's true. So A is true. B says heterogeneous mixtures but not homogeneous mixtures can have a variable composition. Well, here's the thing. What the question is really getting at is who can have a constant composition? And the only folks who can have a constant composition are compounds. So for instance, if I have a compound that's two circles and a triangle, it is always two circles and a triangle, no matter where it is, right? So if I have some kind of container that has these compounds in it, no matter where I sample from the container, I will always pull out a circle, triangle combination, which I just turned my triangle upside down, but you get the idea. Versus if I have a mixture, and let's go with our hearts and our stars again. Here's my stars, here's my heart, here's my heart. And then I have a similar mixture of hearts and stars. If I sample, let's say, from this container, I might pull out a star. But let's say, oh shoot. Let me erase this star here. Let's say I sample from this container in the same way, and in that case, I'm going to pull out a heart, because mixtures do not have constant composition. It depends on where I sample from my mixture as to what I pull out of the mixture. That's the definition of a mixture, has variable composition. And all mixtures have variable composition, both heterogeneous and homogeneous. So letter B, heterogeneous mixtures but not homogeneous mixtures can have a variable composition. That's false, because all mixtures can have a variable composition. So B is false. C says pure substances cannot be separated into other kinds of matter by physical means. That's true. In order to separate a pure substance into other kinds of matter, you have to use chemical means. So that's true. In D, we say the number of known pure substances is less than 100,000. I'd have to look that one up. I think that's probably true, but I'd have to check the textbook. So you can see how important that question is. 26. Let's go backwards. 26. Assign each of the following descriptions of matter to one of the following categories: heterogeneous mixture, homogeneous mixture, or pure substance. In A, we have three substances present, one phase present. So in A, I've got some kind of mixture. I only have one phase, so I only see one thing. But if I had special laser vision, I could know that actually in my mixture I had hearts and stars and smiley faces. Okay? But that's with my secret X-ray vision. If I just looked at the container, I would only see one phase. Okay? It's only with secret X-ray vision that we know that there's actually three things in there, because the problem tells us. So, three substances present, one phase is present. Can this be a pure substance? Well, clearly not, because I have more than one thing present. I have one phase, but I only have one. I have three different types of substances. I have hearts, I have stars, and I have smiley faces. Clearly different substances. Now the question becomes, do I have a heterogeneous mixture, meaning do I see two or more things, or do I have a homogeneous mixture, meaning I only see one? Well, remember, we only saw one thing. So this is definitely a homogeneous mixture. All right, 26B. One substance present, three phases present. So this time, let's make this long and skinny. I have three phases present. Oh, let's make this different colors. And in one phase, I have red hearts. And in another phase, I have, wait, I don't want to use different colors because that will confuse you. I have red hearts as well, but now they're red liquid hearts. So we're going to put a little L next to them because they're a different phase. And then in the third one, I have red hearts, but now they're solids. And up here they were gases. Okay, so there's my 3 different phases I can see, but each of all of the phases all contain the same type of substance. Can this be a mixture? Well, no, because in order to be a mixture, you'd have to have 2 or more things. So this is a pure substance. The fact that I've got 3 phases there, well, that doesn't matter because I only have 1 substance in those phases. Let's look at C. 1 substance present, 1 phase present. Well, same as B. I only have 1 substance present, so that's as far as I had to go. So that's a pure substance too. In D, we have 2 substances present, 3 phases present. So now I've got 2 things present, so it can't be a pure substance, and I've got 3 phases present. So can't be a pure substance, and I can see more than 1 thing. So that makes this a heterogeneous mixture. All right, that was 26. Let's do number 30. Number 30 says, from the information given, classify each of the pure substances A through D as elements or compounds or indicate that no such classification is possible because of insufficient information. All right, so we've got A tells us that A cannot be broken down into simpler substances by chemical means. And that is the definition of, guess what, an element. You can't break it down into simpler substances by chemical means. Compound, you can. Element, you cannot. Here's B. B cannot be broken down into simpler substances by physical means. Well, here's the deal. Elements can't be broken down by physical means, but then neither can compounds. The only thing that can be broken down into simpler substances using physical means is a mixture, which isn't what we have here. So we'd have to say insufficient information. C readily dissolves in water. Well, that actually doesn't give us very much helpful information either, because that's just telling us a chemical property. Elements could dissolve in water or compounds could dissolve in water. So insufficient information too on letter C. Let's look at D. So substance D readily reacts with the element chlorine. Again, we're getting a property of substance D, but it's not a property that tells us about whether we have a single type of atom present or 2 or more types of atoms chemically bound together, which would be a compound. So again, insufficient information. Insufficient. Let's look at 32. In 32, we have to classify the pure substances A through G as elements or compounds or indicate that no such classification is possible because of insufficient information. They do like that insufficient information. So here we have A going to B plus C. So look at this. Here's A. It starts out as something, but after a chemical reaction, that's what this arrow is, suddenly I have B and C. Now clearly A, this was really A was some combination of B and C that when we underwent a chemical reaction separated into B and C. So that means A must be a compound because A was composed of more than one substance. But here's where things get interesting. We can't decide what B and C are because either I could have had a compound that was really just BC breaking into B plus C. Here's what the possibilities of A are. A could have really been BC. Or A really could have been DEC, which breaks into DE plus C, where DE is really B. Wow, this is getting complex. But think about it this way. A could be a compound and break up into elements. Or A could have been an even more complex compound and made 2 new compounds, where B and C are actually compounds. So we don't know what B and C are. That gives us the insufficient information. In letter B on 32, we have D plus E going to F plus G. What do you think? yeah, I can't really decide on any of those. Because D and E could both be elements, or they could both be compounds, or one could be an element and one could be a compound, and the same thing could be true of F and G. So insufficient information on D, E, F, and G. Number 34 says, indicate whether each of the following statements is true or false. A says compounds can be separated into their constituent elements by chemical means. That's true. We can do that. We can chemically break compounds apart. B says elements can be separated into their constituent compounds by physical means. Well, that's them trying to lead you astray, because elements cannot be separated into anything, right? They're pure substances. And they're pure substances of a single type of atom. So I can have an element, like for instance, this would be an element. I have 3 different types of atom. Let's call them all A. And I could break them down, but I could break them down into what? Am I breaking them down into compounds? Nope. I'm breaking them down into forms of the same element. So elements do not break down into compounds. So B is false. Let's talk C. C says a compound must contain at least 2 elements. That's true. By definition, you have to have 2 types of atoms in order to make a compound. So 2 types of elements. So C is true. D says a compound is a physical mixture of different elements. Well, if that was the case, then we could separate a compound using physical means, but we can't. We have to use chemical means. So a compound is a chemical mixture of different elements, and really, let's leave the word mixture out of there because that could confuse you. So this is false. All right, 34. 40. 40 says, indicate whether each of the following characterizations of the elements copper and sulfur is true or false. Number 40. A says, a compound containing copper and sulfur can have a variable composition. Well, no, because compounds don't have variable composition, period. Compounds have constant composition. They will always have the same ratio of elements to other types of elements. B says, in a compound of copper and sulfur, the 2 elements maintain their individual properties. Nope, no they don't. If they did, then water would blow up, and it doesn't, because water does not keep its, it does not keep the chemical properties of hydrogen and oxygen, which are both flammable. Now, that doesn't have anything to do with copper and sulfur, but it gets the idea across. So B is also false. Elements that go to form compounds have new chemical identities, so they have new chemical properties. They don't keep their chemical properties. C says, in a mixture containing copper and sulfur, physical methods can be used to separate the substances present. That's true. In a mixture, we can use physical methods to separate substances. In D, in a mixture containing copper and sulfur, the 2 elements are chemically combined rather than physically combined. Well, it says in a mixture containing copper and sulfur, the 2 elements should be physically combined rather than chemically combined. So they've transposed those 2 terms. So D is also false. All right, that takes us to, I think, our last problem, which is number 70. And 70 says, assign each of the following descriptions of matter to one of the following categories: element, compound, or mixture. So A says 2 substances are present, 1 phase is present, all molecules present are heteroatomic. So we have 2 substances present. So right there, I know that it can't be a pure substance because I've got 2 things. And let's just label them A and B. So if I got 2 things, then it can't be a pure substance because that would only be 1 thing. So it can't be an element or a compound. So it must be a mixture. Now, is it a mixture of elements or is it a mixture of compounds? That's not what the question asked, but it's sort of interesting to think about because it does say all molecules present are heteroatomic. Heteroatomic means different types of atoms. So that means the molecules that I have present must be different types, which means that I must have a mixture of compounds. it's still a mixture, which is what the question was asking. So the answer to A was mixture. For B, one substance present. Aha! Can it be a mixture? Nope, it can't, because I only have one thing. Two phases present. Well, that's not important, because I know it can only be an element or a compound at this point. And then it says one kind of heteroatomic molecule. Well, we just talked about the fact that heteroatomic molecules, those are compounds. So that's what this is. C says one phase present. Okay, that doesn't really help me because it doesn't allow me to distinguish between a pure substance or a mixture at this point. All molecules are triatomic, heteroatomic, and identical. Ooh, now things are getting interesting. All the molecules are identical, so it's definitely not a mixture. And all the molecules are heteroatomic, meaning that, again, we have a compound. D says that we have a diatomic, homoatomic, and triatomic, heteroatomic molecules are present. Good grief. So we've got some diatomic, homoatomic, and triatomic, heteroatomic molecules are present. So I've got some of these. Oops. Let's bond them together. That looks like a pair of glasses. All right, I'm going to erase that because some of you will be confused by what I'm doing. Let's go back. Focus. Let's make them triangles. Okay, so there's my diatomic, homoatomic molecule. Got two atoms. They are both of the same type. So it is diatomic, 2, and homoatomic of the same type. That's an element, right? Because elements have atoms of the same type. And then it says I have a triatomic, heteroatomic molecule. So heteroatomic means different types. So let's bring in our molecule with the 2 triangles and the circle. So 3 atoms makes it triatomic. Heteroatomic means I have different types. So here I have an element, and over here I have a compound. So this must be a mixture because I've got 2 or more substances together. And that's it for Chapter 1.